Hello guys, so in this video I will talk about um, the magnetic field and flux and the induced EMF in a coil. So basically I'm going to talk of coil or a solenoid. So if we talk of coil, it is basically say this is one single coil of wire of length r. So this is now a coil, and if we just stack these coils together, means it just roll a one single wire in this shape, very dense, so it forms a solenoid. And basically these are coils wrapped together like this, and say this length is L, so the length of the solenoid is now L, and the radius still remains the same, like R, capital R, like this. This is single coil where this is like wrapped up many times, and say there are n number of turns. This is number of turns per unit length. So if you talk about the total number of coils, it will be n times L coils in this solenoid. So let's talk of magnetic field first. So if we have a coil and say we have a certain current I flowing in this, so basically we know that the magnetic field will be something like mu naught I in this, and we know that the flux basically depends on um, so instead of talking of mu naught I will not talk of this part. Maybe basically let's talk of solenoid first. So instead of mu naught I, this will be mu naught I times n. Basically this is B is equal to mu naught n I. So this is the magnetic field right now inside this, where n is the number of turns per unit length and I is the current flowing in this wire. Now we know that as the current changes, if current changes, that means magnetic field changes. If magnetic field changes, that means flux changes, because flux is given by B dot ds, where ds is area. If flux changes, that means EMF is induced. If EMF is induced, that means current is also induced, and the current which will be induced will be in opposite direction to the current direction which has produced it. Basically it is according to Lenz's law, which says that anything which induces the voltage, anything which induces the current, that will be opposed by the induced current. So if the current is clockwise, which is producing the induced current, then the induced current will be in anti-clockwise direction. Now we know that B is mu naught Ni. We know that flux will be multiplication of B and area. Area is basically pi r square, which is crossing through this loop. So this will be mu naught Ni times pi r square. So this is the magnetic field, right? And now the flux is through, this is through one coil, this is through one coil of this. Now if we want to calculate the total flux, total, so this will become mu naught Ni pi r square times number of coils. This is the number of coils. Number of coils per unit length multiplied by length gives total number of coils. So this will be equal to mu naught n square pi r square L times I. These all things are constant. Now if we calculate the EMF, which will be equal to minus d phi by dt in this solenoid, this will be now, basically this is a long solenoid, so this will be equal to minus mu naught n square pi r square L di by dt. So basically mu naught n square pi r square L. So if you compare with this equation, which is maybe you can put it this as one constant L di by dt. So if you put this constant, then we can say this constant is equal to mu naught n square pi r square L, and this constant is named as self inductance of this long solenoid. Okay, so if you know the self inductance of the long solenoid, if you know the rate of change of current in that long solenoid, you can calculate the induced voltage. And that's all for this video. So thanks for watching this video. If you have any questions, you can put below and I will try to solve those problems for you. You can just put the number of problem number, or if you want to solve, get it solved, or you want to understand any concept in physics, you can basically just comment it down, and you can like, share and subscribe. Thank you.